All right, so ladies and gentlemen, or anybody subscribing or listening, today we will move on with this example that you see here. Now, if you weren't here last day, that would be Thursday, we talked about this formula yesterday or Thursday afternoon. And we can use isotope mass and their relative abundance, which is given as a percent, to calculate the atomic mass of elements. And this is definitely 100% a question you guys will have to do on your test in October. You'll have to do it on your final exam as well. Now, this is a pretty complicated formula. There's, this sigma means sum or addition. I'll talk about that in a minute. It's a lot easier when you look at the actual method. So we did this problem on Thursday, and I'm going to do this problem today. Now, if any of you have done this, I think your answer should be around 270 something. I can't remember the actual answer, but 272, maybe 273. So if you've done this and you got 272, 273, that's correct. If you haven't done this example, I'm here today to do this with you. So this question you will see on a test for sure, and it gives you a list of 4. This is a big example. I think on a test I would give you maybe 2 or 3 isotopes, but this is a big example. There's 4 isotopes. We have their abundance, and we're going to calculate the average atomic mass for lead. Lead is Pb. Okay, so here we go. It's if I give you this information in a table, this is honestly a really simple question. You just have to watch out for significant figures. So first thing first, 1 mark you guys will get if you change the percent to a decimal. We never multiply with decimals. Sorry, I said that wrong. We never multiply with percents. We always use in math, physics, chemistry, we use percents as decimals. So if you can't remember this from last class, maybe you missed last class or you can't remember, to change percent to a decimal, you divide by 100. And I think, Sophia, you're in this class. Sophia mentioned last week on Thursday, she said, just move the decimal 2 places left. And that's exactly right. If you don't have a calculator, it's easy. If you do have a calculator, divide by 100. So all of these numbers I'm not going to use. So this number becomes 0.014. And again, all I did there is divide it by 100. This number becomes decimal 241. Let me clean that up just for calculation purposes. This becomes decimal 221, and this becomes decimal 524. Again, all I did was divide by 100. And you can do that on your phone, on your calculator, or whatever you want. Or as Sophia mentioned the other day, just move the decimal 2 places or 2 numbers to the right. Now, guys, all I literally have to do here is multiply all of these numbers together and add them up. That's it. So I'm going to multiply each of these numbers and add them. This is typically, this question is how I would ask this on a test. So the table you can use on a test, don't worry. I'm just going to multiply them together and add them up. I have a question in the chat here. Give me 1 second. Yeah, so Aman mentions, it's always, chemistry is always important, and particularly in this situation, be careful about your decimal places. Don't round any of your numbers until the end. So here we go. And I did this a few minutes ago, but, well, an hour ago, but I'm going to redo my numbers here now. So my calculator says, sorry, this is 2, 8, 5, 5, 6. My calculator has a few other numbers. I'm going to leave them off. We don't need too many numbers, but don't round anything till the end. So again, I know I'm rounding a little bit, but I'm still keeping extra digits. I will talk about significant figures at the very end of this question. So let me do the other calculations, and I will explain sig figs. So here I get 49 point, and my phone says a lot of numbers. I'm just going to write 6397. Okay, so I'm just multiplying them, nothing crazy here. So decimal 221 times 206. You can do this on your phone if you have your phones with you, which I'm sure you do. So I get 45.74. Now I'm going to write 17 here. Meaning I rounded the number. My calculator says 45.741696. I'm just going to round it to 7. I always tell you to round at the end, but you don't have to write a million numbers. Just keep a few extra numbers that you think are important. Okay, so I multiplied this one and I get 108.9799. Okay, so all I'm going to do now, because I've multiplied these together, this, by the way, is called a weighted average. I multiply them all together and then add them up. And Iman in the chat says, should we only choose 4 to 6 numbers at the decimal or all of them in the exam? And that's an awesome question. So Iman and everybody listening, honestly, on the final exam or test, keep 4 to 6 numbers. Iman, you had it perfectly stated. Just keep some extra numbers. So 4 to 6 is fine. I don't need to see 10 or 12 or 20 numbers. Just 4 to 6. You couldn't have said that any better. So, and this took me a few minutes this morning or earlier today. Before you do this calculation, we need to think about significant figures. Okay, so this is honestly the hardest significant figure question you would ever see. Nothing in chapter 3 or 4 or 5 would ever look like this. This is a challenging significant figure question. So first, look at this number. I'm writing it in purple if you can see me writing. This number only has 2 significant figures. So I multiply them together, which means only these 2 numbers are significant, 2.8. Okay, that's fine, no problem. But this is where this question gets tricky with significant figures. And don't worry on a test. If you get significant figures wrong on a test, you're only looking at 1, maybe 2% of the total mark. So I really don't want you guys to panic about significant figures. Just try your best. If you're one of those students who want 100, you need to get significant figures correct. Again, if you get this wrong, you could still get a 98, 97, something like that. So, okay, this is where this gets tricky. Look at this example here on the bottom. I'm circling it in purple. This is 3 significant figures. So that means this number, the 108, only has 3 significant figures. So that means when I add this all together, I take no decimal places. DP means decimal places. So my number here cannot have no decimal places. And Aman mentioned in the chat, if I'm the one who's marking your test, it's fine. I am definitely the person marking your test, which means I will promise I will go easy on you on significant figures. Again, you might lose 1% or 2%, but it won't, you're not going to fail a test because of significant figures. For the few students in my class who are, and I always have a few who just want to get 100 on everything, if you don't do significant figures right, you will not get 100. So my answer cannot have decimal places. So all I'm going to do, guys, is add these numbers. That's it. So I'm putting them in my phone now. I'm literally just adding them up. And just give me a second to do that. Okay, and adding the last, oh no, guys, sorry, I messed up. Hold on. Give me a second. I put in the wrong number. And if you guys are doing this yourself on your phones or calculators or whatever you have, I think the answer should be around 207. I just messed up. All right, here we go. One more number. I should bring my calculator back from the office instead of using my phone is really what I should do here. But anyways, here we go. 9799. Okay, cool. So I get, and I see some messages in the chat. I'll open them in a minute, but I get 207. Let me change my color here. Now, this is what I get. This might not be what you get, because depending on how you rounded your numbers, you might see something a little different. But what I get is 207.2. So my answer is 207. The units for this, you could use AMU or grams per mole. We'll talk about units later. This is not important for now. But if you did this along with me, you should get 207. I'm looking at the chat. I'm getting, yeah, 207. This is perfect. So we, Humna in the chat asked about rounding. Notice I do not round any of these numbers until the last step. So, keep a couple extra digits when you're doing this on your test or final exam. And I only rounded it at the very last, step. All right. Let me check the chat. And I think yeah, so Raman, your name, I can't see your first name, but you said grams per mole. That's technically what we will use in the future. We'll talk about that in unit 3. So the concept of units, AMU, grams per mole, whatever you want, we'll talk about that in unit 3. Aman in the chat asked, why is there no decimal places in my answer? And very quickly, I can explain. If you look at the significant figures, I'm using purple. So you'll see purple now in a second. Sorry, that should be 1. If you see, so this number I'm circling on the table on the left, this has 3 significant figures. So what that means is this number, when I multiply these together, this number only has 3 significant figures. So what that means is no decimals. Because this is only 3, my answer has to have no decimals. If any of you guys are really, really struggling with significant figures or decimals or even anything I've talked about, a few things you can do. You can always visit me on Sunday or Monday in my office, and there are always online for you worksheets with answers, and this is on D2L. DL2, D2L, sorry. I had an email pop up, my brain just broke. So if any of you want more work on significant figures, worksheets, anything like that, it's all on D2L. And you can always email me, or on Sundays, Mondays, and Tuesdays. So Sunday, Monday, Tuesday, my office is in building 7. Okay, so guys, it's 3:03. I have 2 more slides to show you. 2 slides and we're done. All right, and this is easy, it's quick, and we'll basically do these 2 slides and that's it. This is also a test question, you'll see. So we've talked about isotopes, we've talked about atoms, we've talked about all sorts of things. Some atoms or some isotopes are not what we call stable. And what I mentioned to the other class is, think about when in your kitchen or in your house, you cut an apple or you cut an orange, or sorry, not an orange, a banana. After, maybe 30 minutes, 60 minutes, that apple or that orange turns brown. It's reacting, it's not stable. Once you cut it in half, it's reacting with the atmosphere. More particularly, it's reacting with the oxygen in the air, and it turns brown. Well, isotopes can be similar. Certain isotopes are not stable, meaning if we leave them in nature, in the environment, and we let them react, they decompose or they break apart, just like an apple or a banana if you cut it in half. So, one multiple choice question you might see on your test in October is which isotope, which atom, again, nuclei is the fancy word, but I just mean isotope, which isotope is stable? Well, basically, it's this rule on the bottom. You would see an unstable isotope or an unstable nucleus will meet three criteria, or will have one of the three things I've listed here. So number one, if the element or atom or isotope has an atomic number bigger than 83. Okay, so that's just one above lead, Pb. If the atomic number Z is above 83, it's probably not stable. Two, if your number of neutrons is less than your number of protons, and we will talk about this in a minute. And then the last one, if the atom or element or isotope, whatever you're talking about, has odd protons and odd neutrons. Odd, we call it. Even, you can see it up here in this note, even is good. When you have odd numbers, meaning odd protons, odd neutrons, it is not stable. There are examples here, or sorry, exceptions. You don't need to study those. Don't worry about these. Not on test. On a test, I will never give you something confusing or like an exception to the rule. So don't worry about this. So here are three examples. I'm just going to take maybe 3 or 4 minutes to do this. I will do the first one, and then you guys can try the second two. So here we go. This is probably the easiest one. So this question says, identify the unstable nucleus, or again, in simple words, identify the isotope that is not stable, or is the least stable. So here I have 208 and 82. Remember, the 208 is our mass number, and the 82 is our number of protons. Now, reading the rules, if I go back one slide, if the number of protons, Z, is over 83, like this one, it is not stable. So my answer to this question would be, this is called radon. And the reason this is unstable is Z, or my number of protons, is bigger than 83. So this is a tough question if you've never seen me do it, so don't worry. But I'm going to give you guys a few minutes to look at these two numbers, or these two examples, and tell me which ones you think are unstable. So I'll pause my microphone, and I'll be back in 2 minutes. All right, so let's look at these questions or answers. So, okay, neon 19. We call this chemical here neon 19. So this chemical, neon 19 we call it, would have 10 protons and 9 neutrons. Now, how did I know that? Well, 19 minus 10 is 9. So the other chemical, neon, we would call this, in English, neon 20, has 10 protons and 10 neutrons. So this chemical here is even. It has 10 protons, 10 neutrons, no problem. This chemical is your unstable chemical because the number of neutrons is less than the number of protons. So my number of neutrons is less than protons. So this chemical, the one I've circled, is less stable because it doesn't have as many neutrons as protons. This is another example that can be a little challenging. So we have 63 and 29 for copper, and we have 64 and 29 for copper. So let's see how many neutrons we have. Obviously, we have 29 protons in both. That's literally what makes copper copper, is the fact that it has 29 protons. So all I do is I subtract these numbers and I figure out that this guy has 34 neutrons, and this guy over here, the copper 64, has 35 neutrons. Again, these numbers come from just subtracting the mass number minus the atomic number. Okay, so guys, looking at this, 29 and 34 or 29 and 35. This is an odd situation. Remember, odd means 1, 3, 5, 7, 9. And because these numbers are both odd, 9 and 5, this chemical here, copper 64, is not stable. So guys, that's it. I have another class to get to, so I'll stop the recording. And if you guys have any questions, feel free to let me know in the chat.